Now that you can create a list, the question is, how would this be more useful, right? What would be the point of a list of movies playing if you couldn't search for the one you wanted to see? Or a to-do list if you couldn't remove the items you already completed? Well, by the end of this lesson, you'll have a pretty good idea of how all of this is accomplished. You've learned the basics for making a list, right? How to set it up, how to get items into it, but let's look at how to actually process it. Processing means that you're instructing the computer to make some sort of calculations, okay, to go through that data and do something with it. In this lesson, we will look at situations where we want to perform the same operation on the entire list, okay? Like, for example, we want a sprite to read the whole list, and we know that's possible because you saw that in the previous slideshow. We'll look at situations where we want to instruct specific actions to occur on specific items in the list, okay? So as a simple example of that, we would instruct the sprite to read part of a list, or just one item of a list, or particular items out of a list. All right, and we'll start by seeing what to do when we want to have a character read all of the names from our players list. This is a really common type of problem when dealing with lists. We have a list for a reason, and we want to do something with the whole thing for each item in the list. What we're going to do is actually create a variable called index. So I don't know if you remember when we introduced lists and we talked about how there is something called a for loop that allows you to go through a list. And actually, even in text-based programming, you can use a for loop. It doesn't have to be on a list. It can be anytime you want to go through and do something to multiple numbers or variables or something like that. All right, so what we're going to do is create a variable, and you've done that before, right? In Scratch, we're going to create a variable called index. All right, an index is actually going to track what place on the list we're on. So if you remember, in a for loop, there was this little letter I, and it was something like the initial condition was I equals 0, and then I is less than, let's say, 6, and then it was like I plus plus. Okay, and we said that the first section, usually these are separated by commas, the first section is the starting condition. All right, well, here you go. Here's your starting condition. All right, this next one over here, I less than 6, that is the condition to continue. Okay, so this 6 doesn't have to be the number 6, it could be the length of list. All right, I less than length of list. That is the condition to continue. So as long as you're not at the end of the list, keep going. Really, I guess we would probably want to, in this situation, I less than or equal to 6, or the length of the list. Actually, 6 is longer than the list. Anyways, never mind. You get the picture, all right? And then this says that we increment the variable, okay, that I is going to be incremented. Well, here you go. Right here, change index by 1, okay, by a positive 1. So this is like a traditional for loop. It's just that Scratch doesn't set it up as such. And remember that on the APCSP exam, you will see for loops used in lists. It won't have these 3 things over here, so you can just forget all about that for the APCSP exam anyways. Now when you get into text-based coding, you'll need to remember it again. But this is how we're going to look at it in Scratch. Now you get a chance to try this out on your own. In this try it out, you will use an index variable. So you're going to want to create that variable index, and you're going to use it to say an entire list of names. Just as a quick clue, you will probably need to create another variable as well to hold all of the names. Additionally, we'll try to not just say all of the list of names, but maybe just some of the names from the list. At this point, you'll want to switch over to Scratch and give it a shot. So what happens when we want to actually remove items from the list? Think of this as a table of, for example, students. And we just graduated all of our seniors. And so now in all of our databases and our grade books and things like that, we need to remove the seniors because they're no longer students. So we have a giant list of students and we need to remove anyone who is in grade 12. And then we need to set everyone else who was in 11, we need to set their grade to 12 now, right? So how do we do that? How do we accomplish removing items from a list? Well, here is a sample script. And you've got access to this, so you're going to get a chance to try it out as well. Here's our good old index variable, okay? And we're going to set our index to 1 because in Scratch, the first item in the list is 1 and not 0. We are going to repeat for however long the list is. If the list has 8, we'll repeat it 8 times. If the list has 7, we'll repeat it 7. All right, we're going to look and see, it makes sense here that if the condition is met, here's our Boolean, if this condition is met, that whatever item we're on, let's just say, for example, that the first we're on item 1 because it was set to 1, equals ABC, and we already know that this is not so much case sensitive, then we're going to delete it. All right, so it means we're going to cross it off our list. It will no longer exist. We'll change our index by 1. We'll increment our variable right here, and then we'll move on to item 2. Let's try that out. Let's see if it's really as simple as it seems. So as we found out, it seemed at first hopeful that it would indeed be as simple as it seems, but it wasn't. We had to do a little bit of work. So see if you can figure out the answer to the reflection questions. When does the script not work? Well, we saw that the script actually doesn't work in situations where the item that we want to remove is currently sitting at item 2, like this guy right here, okay, this DEF. When we switched to remove DEF rather than ABC right here, DEF was at spot 2, okay? It was also in spot 1, by the way. So when item 1 was removed, we saw that this shifted up, became the new item 1, but the index variable had already incremented, and so it was missed, all right? So that's a situation where this script does not work, and that's why. Because the values of the index shift up 1 every time an item is removed, all right? And so in general, what type of list wouldn't work with this script? Well, lists where there are multiple values that are going to be removed, as we saw, or anytime items are sitting in a spot below index 1, right? Especially at spot 2. So the question is, how do we fix it? And we saw that we can either decrease the index variable, we increment by -1 if an item is indeed removed, or we can just increment the variable only if an item is not removed, right? So that kind of saves us, all right? So hopefully you enjoyed that and you're ready for a little bit more complex list processing in the next lesson.